Haley, it's great having you with us here at TechForge. Getting to the nitty gritty, let's just start off this conversation that we're going to have with you. So, to start us off, can you give our viewers some context of your experience in the IoT sector?
Absolutely, and great to be here. Great to be here. Yeah, so first, I grew up at IBM in engineering and later managing networks and communications portfolios. And I moved to Silicon Valley after that, focusing on high availability telecommunications products for several companies here. But my work in IoT was really started with a hardened industrial edge device company, a business we ultimately sold to Belden. But then I continued my work in IoT at General Electric, where we built a lot of industrial IoT solutions across different vertical markets using GE's Predicts, as well as integrating into other customer initiated IoT solutions. But for the past 5 or 6 years, I've been the CEO of IoT83, where our focus has been to democratize IoT platforms. At GE, I could see the huge benefits of industrial IoT, but also the huge cost required at the time. So our focus in IoT 83 has been to completely change this dynamic and make IoT value creation much more streamlined, but still provide the security, scalability, and reliability that industrial customers really need.
With that background, can you give us your view of the current state of IoT in 2024 from a market adoption and IoT value creation perspective?
Yeah, that's a great and a very interesting question because it's like we're living almost in two worlds. On the one hand, companies that have successfully deployed IoT solutions are seeing very real differentiation and competitive advantage directly tied to these deployments. But on the other hand, per McKinsey, there's some 70% of IoT implementations that completely fail to meet business expectations. In another McKinsey article, they say over the past 3 years, the gap in digital and AI maturity between leaders and laggards has increased by 60%, and that these leaders are not just making IoT and AI generate value, but they're building momentum and more gap between themselves and their competitors. And this is huge. In that same article, they say that the leading companies are outperforming laggards by 2 to 6 times on total shareholder returns. 2 to 6 times. So this is huge. And it's like we're living in two worlds. And what this McKinsey article is saying really may be understated if we look at how IoT and AI are likely to permanently reshape market dynamics over time. First, these market leaders we just talked about will use this differentiation to build moats around their success with IoT and artificial intelligence. And as a result of that, these leaders will be able to define how products are sold and priced across their addressable market. For example, where pricing for industrial equipment used to be a one-time sale and maybe a support contract for services, now a clear leader could cut the initial purchase price and make that up and much more by selling annual IoT software licenses. And any company without a similar IoT offering would just be out of luck and out of the equation. And really, this goes further because as a leader that sells their customers on the IoT solution also gets a lot of account control on what the customer buys, because the customer will want the best smart edge devices that fit into the strategic path they chose. So again, any company without a strong IoT solution is again left out. So what's going on here? The business leaders that are lagging in IoT, digital, and AI transition, they understand all this, but for a lot of different reasons, such as cost to implement, technical complexity, or skills gaps, their programs have not been successful or even gotten off the ground. I guess my key message on all of this is that the time for industrial OEMs and enterprises to make a big push for success in IoT, digital, and AI transformation is now. Done right, these businesses gain huge advantage and lasting competitive advantage. Done poorly or not done at all, it's probably not unfair to say it could be disaster.
Seeing how all these advanced, technologies really evolve and trying to evolve, change and shift certain businesses, it's actually very, very tremendous, right? And it's kind of like to say that like these advancements actually help other businesses advance as well, right? Not just helping the technologies advance, but also evolve as a company as well. So can you give us like a few examples of customer deployments that you have seen where their businesses has had this kind of massive success?
I guess I've got three quick examples. The first one is an IoT program we did with Verizon. The need for this solution came from the huge growth of Wi-Fi devices in the home. With one or two devices connected in the past, service agents could generally handle customer problems. But once it got to 10 or more devices, they had no idea where to begin. And this was a huge problem and a lot of customer dissatisfaction and frustration on all parts. So we worked with their prime Wi-Fi router supplier to put a smart agent into the router to gather data on all the devices in the home, the signal to noise ratio, signal strength, everything, and to collect data from the router itself about the overall Wi Fi environment. And now we connected these feeds from some 5 million homes and data from about 50 million devices and fed that into our Flex 83 platform. We built some specialized analytics, workflows, and dashboards to make service agents work easier. This was a huge success. Immediately, customer satisfaction went up and service costs went down. A huge success with material business impact. They continue to use this and add a lot of new analytics to the data that they were getting from these devices that has continued to deliver value for them. Another customer, True Manufacturing, started off with a pretty typical IoT plan and roadmap. They instrumented their industrial, residential, and ICE machine products and used our platform to build asset monitoring and remote asset management. But once that was done, they started to see huge value out of the data they were getting. Now they're using IoT in manufacturing to improve quality. They use IoT data to lower service costs while improving the quality of service. And with this data, they're able to drive dramatic and business material warranty savings. So their deployment exceeded expectations, and really they're just getting started. I guess the last one was a very large OEM that invested big on getting all of their hardware up to the smart product level of capability. But really, their progress stalled in terms of transforming all of this data into value creating applications. So we partnered with them to use our application enablement platform, and now they can quickly build enterprise grade applications across their product lines, putting them ahead of the game versus their competitors. So now with this foundation set, they're continuing to layer on new value from an analytics, automation, and artificial intelligence perspective. So again, another big win from a long-term and strategic value perspective.
You talked earlier about how many IoT programs fail, right? So what is happening on the technology side to make this better? And what key trends do you see shaping the evolution of the IoT space in the coming year?
So there's a huge amount of investment going on in the IoT space, and as a result, the entire industrial Internet of Things ecosystem is improving pretty quickly, and this is really important in driving new program success. But looking at the IoT technology ecosystem, there are really two parts of the equation: the smart edge, and then the big data smart applications that transform this smart edge data into the real economic value. So smart edge first. I think we're already starting to see a proliferation of smart edge deployments, and this will continue to grow quickly. It's certainly true with lower cost, lower complexity data gathering and control devices, like in the home, smart thermostats, doorbells, smart cameras, security devices are all examples. But in industrial settings, this is more complicated, and the use cases are more diverse. In industrial settings, enterprises and operators need to connect all sorts of sensors to machines, processes, or industrial environments. And until recently, they had to pull all of these solutions together more or less from scratch on their own from different sensors, edge processors, routers. And this was a big, big headache and challenge. But now we're starting to see the IoT ecosystem provide more turnkey and integrated solutions for targeted industrial processes. I fully expect to see more of this, and this will get easier. But we're also seeing accelerated deployment of smart edge capabilities on this is different on capital equipment itself. So these high dollar industrial machines used in manufacturing, energy management, smart farming, transportation, et cetera, are all being instrumented with smart edge data, sensors, and communications. The big reason for this is you can now protect these high dollar investments by monitoring the equipment being used and service that's being used and serviced correctly. And the second, of course, is to get the most value out of these investments. You know, smart farming with smart tractors, et cetera, is a really good example of this. So, at least from an edge perspective, I fully expect this to advance as well, both on the sort of smart product perspective as well on these sort of high dollar smart asset perspectives. But that's just the smart edge. We really need to see a lot of advances on the big data analytics and insights side of the equation because that's what really brings home the value of the smart edge. Without this, the smart edge data is just stranded. These IoT platforms historically have been way too complex and expensive and have delayed industrial IoT economic value delivery. And this has been improving, but we need to see continued advances in making it easier to transform all of this smart edge data into scalable and secure enterprise grade applications. We can talk more about this later, but this is where IoT 83 is totally focused. We're totally focused on changing this and making this far more streamlined. So I think the smart edge piece of the equation's gotten easier. I think it'll continue to do so. Really, this piece of the puzzle is the easier piece because it's more self-contained and more familiar to industrial OEMs and enterprises. The big data, smart application side of the equation has been the biggest challenge and the biggest obstacle to success, I think, for a lot of these programs that have failed to meet expectations. Again, it's gotten better, but really not enough. And this is our full focus at IoT 83.
So if the big data, so-called smart application side of the equation is the biggest impediments to success, can you elaborate on what the, IIoT ecosystem needs to provide for OEMs and enterprises to make them more successful?
Yeah, we put a lot of thought into this at IoT 83. Uh, you know, we really need the ecosystem really needs to provide them with relief in two main areas. First, OEMs and enterprises need relief on the complexity of building and deploying big data and industrial IoT systems in the first place. For the most part, OEMs and enterprises have specialty skills that are focused on what they build or operate. But generally, they don't have big data platform scalability, cybersecurity, or AI ML expertise. So, industrial IoT platform solutions that require all these skills are requiring these companies to either hire them or train up these skills or outsource all of this work. And from their point of view, this is just too risky an undertaking. So, solving this big skills gap is really important. And I think we can do that through better technology. The second thing that OEMs and enterprises need is for the IoT ecosystem to resolve a core conflict that almost all these businesses have. On the one hand, they need an application creation and deployment solution that gives them cost, schedule, and risk management, as well as true enterprise grade solutions that are scalable, cyber secure, and reliable. But on the other hand, and in direct conflict, they need the ability to deliver custom solutions. Because without the ability to build custom solutions, they have no path for the kind of differentiation that they really need to win in the market. So today, these two things have been in direct conflict. On the one hand, you could have lower cost solutions that were more or less fixed from a differentiation and customization perspective. Or on the other hand, you could have customization and differentiation, but a very high cost. So this is the next big thing that the IIoT ecosystem needs to solve, cutting or even eliminating this conflict.
As you said earlier, your company is heavily focused on solving these problems. So, can you share your approach to making this a reality?
When we founded IoT 83, I was just coming out of GE where we were using predicts to build very large scale IoT applications. And really, you had to be a very large business to afford it. At the same time, and this was really interesting, IBM was starting to talk about what they called Blue Mix. With Blue Mix, they were using carefully curated open source components to build highly scalable big data solutions with a lot of success. So, seeing the affordability and flexibility problems with these mega IoT solutions, and also seeing the viability of a new, smarter path started us in the direction that we're on now. So, with this as a foundation, we've started IoT83 to solve the conflicts in the ecosystem we just discussed. But so also when we founded IoT83, we were looking at the whole IoT big data platform ecosystem to see what was wrong and why so many programs were failing, and really trying to put together a new recipe for success. So, like I was saying, the first IoT platforms on the scene were these mega platforms from the big multinationals like GE. They provided scalability, security, and extensive functionality, but they were very expensive and almost exclusively suited to managing the resources from that company. If you had a lot of GE equipment, it made great sense. If you didn't, it didn't make any sense at all. So we saw the main constraints of these solutions as very high cost and very low flexibility. So the next IoT platform wave was in industrial IoT as a service solutions from the likes of AWS and Azure. So with the depth of these platforms, this solved the inflexibility problem and let companies build virtually anything. And it fueled a lot of innovation. But as companies tried to go beyond proof of concept from MVPs and POCs, they realized that with all the needed security, reliability, serviceability, the huge skills, time, and engineering costs became apparent and really insurmountable. So we saw the market constraint of these solutions is again cost, even though the flexibility problem was solved. So then the next wave, in direct response to the complexity problem, came the low code or rapid application development platform. Here, these platforms provided basic IoT workflows, and with low code tools, OEMs could produce use case specific IoT solutions. But for a lot of OEMs and enterprises, these sort of set workflows were too limited, and they just couldn't build the kind of rich solutions that they needed. So our take on this wave with these low code solutions will really never be enough for enterprise class applications. So this was all in front of us real time. We founded IoT83 and we started building our Flex 83 platform. With this in mind, three goals that we set for ourselves. First, the solution needed to just work out of the box like the mega IoT solutions and also stand up to full enterprise grade requirements of scale, cybersecurity, and reliability. And second, like IoT as a service, the solution needed to provide extensive application creation and customization flexibility so that our customers could have the differentiation that they really needed. But this was the hard part. We had to provide this by minimizing any material increases to time, skills, risk, and cost from this flexibility. And then the last piece, there really was value in these rapid application low code platforms. And so we knew we needed to also leverage low code methodologies so that once the solution was completed and built, customers could get the most value out of it without very much effort. So now, 5 years development later and enhancements to the Flex platform, we feel that we've delivered on all of these goals. Really, this is interesting too. Now we think of Flex not as an application enablement platform, which is what we were originally labeled as, but more as an application creation factory.
That is very interesting and makes sense. But can you give our viewers more detail on what your Flex platform is and how it is fundamentally different from other solutions?
This is going to be a lot because it is. There's a lot to say here, and I really wanted to discuss this because the layers of value that we built into Flex, I think, are really what set us apart from everybody else. So let me start first with the foundation. As the foundation, we curated what we found is the best open source big data infrastructure code like Kafka, Terraform, Kubernetes, high scale data brokers, and a lot more, and built a highly scalable and reliable underlying platform foundation. Now, because it's built using the best of breed open source, we're able to port this from AWS to Azure to private clouds and even on-premise applications, which is a huge advantage, particularly in industrial OEM and enterprise settings. And this core has now been proven at scale to more than 50 million devices in a single instance. But the next layer up, and this is key to our solution and the heartbeat of all our applications, we built the Flex Platform Core Services layer. So what this is a set of 32 and growing as we add more and more services, 32 services, really middleware that are at the heart of all applications and solutions built on Flex. Um, Examples of these core services range from device database and third-party connectors to ETL transformation services to analytics to identity access management, notifications, scheduling, AI ML model building, and a lot more. And unlike other alternative solutions, the Flex platform provides direct developer access to these core services via secure APIs accessed through very well documented SDK code. So by using the Flex SDKs and core services, developers only produce a very small fraction of the overall product lines of code to generate extensive, intrinsically enterprise grade and custom applications and solutions. So using the Flex SDKs, developers are swinging a really big hammer because they don't have to touch the underlying services. They just use them. This minimizes the risks for reliability and security and cuts out new code defects, validation costs, and long-term maintenance costs. But that's the services and the SDKs and the secure APIs. But even with all of this, there's still a lot of work to build a complete and coherent application. This is where the next layer of our solution comes in, the hardened application catalyst code. So this catalyst code is provided to customers as source code that they can modify and edit to create their custom application, but it's a complete industrial IoT application in itself, fully validated for scale and security. It includes industrial IoT functions ranging from device connectivity to data transformation to storage to analytics to notifications to identity access management and more. And it can be used as is out of the box. But this is not what we expect. This is sort of the magic here because most industrial OEMs and enterprises want their own competitive differentiation. We've talked about this before with the custom context for their applications. So, like the name, this application is more commonly used as catalyst code. But this is powerful. With this catalyst code, OEMs and enterprises can, as our developers say, lift and shift the provided IoT functions to quickly build almost any functionality they might need in a custom solution. They can rearrange the flow or sense of the application. They can change the actual analytics used. They can add whatever custom application logic they might need, or even customize the widgets for some specialization for their particular vertical market that may be used in the dashboards to meet their specific goals or application needs. So between the services layer, the catalyst code, the amount of new code that developers actually write, as well as the need for specialty data, big data platform skills, they're both dramatically cut to a minimum. All right, so that's the we have the the architecture at the bottom, the core services, the catalyst code. The last layer is the Flex Data and Analytics Studio. This is where we leverage the low code capabilities that we were talking about before. This studio application is a ready to use application that lets you securely connect to virtually any internal or external data, transform and store that data, perform analytics, including AI and ML workflows, build derived data, and then using the studio's drag and drop dashboards, you can build custom dashboards and shareable applications. For example, product managers can explore data to build new features that might be important to customers. Or data scientists can build new AI and ML models or custom analytics to build new predictive maintenance or prescriptive maintenance solutions. But once they're done with these applications, They can be launched using the integrated identity access management tools to whatever user they want to share this with. So, all taken together, Flex is a very powerful solution that the ecosystem has just really not seen before. It works out of the box like the mega IoT solutions and like the IoT as a service alternatives. The solution is more or less infinitely flexible in terms of what you can build. But compared to these IoT as a service solutions, using Flex is hugely simplified. The underlying architecture is scalable and secure. And through the combination of the core services and the Catalyst code, the number of new lines of code needed to build a completely custom application is actually really small. Finally, using the Data and Analytics Studio, citizen developers and data scientists have got just huge flexibility in building new application value. So I knew that this was a lot, but to take in all at once, when you take it, put it all together, this is Flex 83. We call now the application creation factory.
It is very impressive, and I see why you and your team are so excited about Flex. But on a somewhat different note, we have not talked much yet about AI, ML, and generative AI that will influence the IoT space. So, can you give us your view of how these technologies are being used now and what you expect to see in the near future?
It's really been really interesting. From the start, we built AI and ML workflows into the product, anticipating that our industrial customers would use them right away. But really, a lot of our OEM and enterprise customers are laying their long term foundation for value creation, and their focus has been building out the smart edge and then creating and deploying their custom applications to build value out of this smart edge data. So, surprising to us, AI, ML, and even generative AI is all taken sort of a back seat to this. But in working with our customers to really dig into the data, integrating AI and ML models into a lot of different parts of the applications, we can see, and they recognize as well, that this is going to be a huge value. For example, in predictive or preventive maintenance solutions, threshold-based rules will only get you so far, and you really need AI and ML models to do this right. Across their applications, using AI and ML on all the smart edge data coming in long term is going to be essential to realizing the full economic value from IoT solutions. So we emphasize this with our customers, and we've even built these extremely streamlined workflows to create, tune, and integrate AI and ML models into their solutions as a part of our platform. Using these tools, we simplified the process of data cleaning and management, actually building the models, and finally to launch the models and running applications. But on generative AI, uh, IoT83 is first looking at how we can leverage this as an interactive guide to help or even automate how customers actually build applications using our Flex platform. That seems like a really natural next step we talked about making how important it is to streamline this and make the application creation far simpler for these OEMs and operators and to bridge that skills gap. We bridged the skills gap already with the different layers of value that we talked about before. But this generative AI, I think, can take this still further. For answering questions about how to use the platform, to showing customers how to use the SDKs and APIs provided in the platform core services middleware, to even generating code for applications. We think generative AI has got a lot of potential, and we were really looking forward to integrating this into the product, which is a big jump forward, but it is going to take us more time really to bring that to market.
This has been a great discussion, but do you have any closing thoughts for our viewers before we let you go?
I guess I have two thoughts. You know, the first part of our discussion about the benefits that companies are seeing where they were successful with IoT is probably the most important thing we covered. Uh, the idea that companies that are successful are outperforming their competitors by 2 to 6 times in total shareholder returns is amazing. It's great news for the successful companies, but also scary for any companies that may be lagging here. I guess, but the second thing though is, now that there have been so many advances in the IoT ecosystem, OEMs, enterprises, and operators don't have to take the economic risk of lagging in this anymore. We talked a lot here about our Flex platform, but there are other advances as well across the IoT ecosystem that are making IoT, AI, and digital transformation far easier. So, my closing thought is how important it is to take advantage of all of this to be one of the companies that wins as this industrial IoT, AI, and digital transformation megatrend unfolds.